Let's discuss problem number 6. Here where we want to take a limit. So if you want to do a quick check or quick substitution, you realize essentially what you have is 1 to the power of infinity structure where we want to do logarithmic differentiation. So you can simplify the problem a little bit if you want to. One way to look at it is to take natural log. So you have log of this whole problem, 7x over 17x plus 10 to the 8x, right? I'm solving a modified version of the problem, which is mathematically equivalent to natural log of the whole expression. And therefore, we can move the exponent right in the front based on the property of logarithmic function. So it's 8x multiplied by ln of 17x over 17x plus 10. Sorry, part of my handwriting. So if you look at it, this goes to infinity. This is like ln of 1, so it's like infinity times 0. You choose whichever was simpler to put down the denominator. If you really don't like to deal with the coefficient, you could have put the coefficient out in the front. Either way works. So if we go with that, let's pull the coefficient out in the front. Then I've changed one of the factor to be on the denominator. So I end up with x to the negative 1. Well, this one, as you can verify very briefly, it's ln to the ln of 1 and 1 over infinity. So this is 0 over 0 structure, so you can use L'Hopital to solve it. So it's 8 times limit x goes to infinity. You have negative 1x to the negative 2. You want to take derivative of this function, which is a log of something. That's supposed to be the same as derivative of what's come behind the log over itself. So for simplicity purpose, let me put the calculation on the side. So I'm moving myself to the side. 17x over 17x plus 10 takes derivative. You can either simplify algebraically or you can use quotient rule. Either one works. Quotient rule says it's derivative of the numerator at the denominator minus the numerator times the derivative of the denominator divided by the denominator squared. So you end up with 17 times 17x plus 170 minus 17x times 17, which are the same as the expression before. So what you end up with is 170 divided by 17x plus 10 squared. You find your derivative, you put it back into where you stopped earlier. It's multiplied by limit, x goes to infinity. So you end up with 170 divided by 17x plus 10 squared. That's your denominator. This is their equivalent. And then you divide it by 17x over 17x plus 10. And then you divide it by negative 1x squared. Sorry, x to negative 2. So you can make your life slightly easier by simplifying the structure. So one thing you could do is you could multiply x squared to the top and bottom, right? So there's a quick cancellation here. But also you may notice that this term 17x plus 10, 17x plus 10, they appear repeatedly on the numerator and denominator up here. So the other thing you can do is you can multiply 17x plus 10 multiply 17x plus 10 for simplicity. So what you end up with is 8. You have limit x goes to infinity. You would have your simplification canceling those two terms out, canceling one order out. And what you end up with is you have 170. You have divided by 17x plus 10. And then you have divided by 17x times x squared divided by negative 1. Divided by negative 1 is useless, right? It's just a matter of change of sign. So I'm getting rid of that and put my minus up here in the front for simplicity purpose. Then I can continue with my cancellation. I can cancel 1x, right? And then I can cancel the 17, so it has 10 left off there. So what you end up with is 8 times limit, x goes to infinity. You have negative, you have 10, you have divided by 17x plus 10, and everything on the denominator is canceled, so it's have 1 left. Then you also have your multiplier x. So you end up with 8. You have limit, x goes to infinity, negative 10x over 17x plus 10, which if you take another look, is infinity over infinity structure after substitution. So what you end up with is 8 times limit x goes to infinity takes derivative on the top and bottom. So what you have is, I believe, negative 80 divided by 17. And then don't forget you are solving a slightly different problem. You take log earlier, so your final answer is e to the negative 80 over 17.